Steve jumps off a building with a height of 100 meters. If Steve has a mass of 70 kilograms, what speed will he be traveling at just before the point of contact? What is the momentum right at the point of contact? What is the average force Steve feels from the ground if the collision time is 0.31 seconds?
Here we have our well-drawn building with Steve at the top. He's 100 meters above the ground and he is ready to jump off and splat right on the ground.
We know that the change in energy equals delta U plus delta K. Therefore, we can say that negative U equals K. From that, we can say negative mgh equals 1/2 mv squared.
After some algebra, we find that v equals the square root of 2 times 9.81 times 100. Then after plugging and chugging, we find that the velocity Steve has just before reaching the ground is about 44 meters per second.
From that information, to find the momentum, we multiply Steve's mass, which is 70 kilograms, times Steve's velocity, which is about 44 meters per second. After plugging and chugging, we find that Steve's momentum is about 3,100 kilograms times meter per second.
Using that information, we can find the average force inflicted on Steve by dividing the momentum by the time of collision. After plugging and chugging, we find that Steve feels about 10,000 newtons of force.
We know that the ground exerts the same amount of force on Steve as he exerts on the ground because of Newton's third law. We also know that before Steve jumps, the initial momentum is 0, and after he hits the ground, the momentum is also 0. This is because of conservation of momentum.